So this is Geometry, Chapter 3, Section 3, Proving Lines Parallel. Our learning objective is to determine whether two lines are parallel. And you can't do that just by looking at them. Just because they look parallel doesn't mean anything. We are now in the business of proving that. All right, so the first item we're looking at in the section is Theorem 3-4, converse of the corresponding angles theorem. So converse, we learned, means we're switching the conclusion and the hypothesis around. We learned that in the last chapter, in chapter 2. So corresponding angles theorem was if two lines are parallel, then their corresponding angles are congruent. So when we say converse, so if you know what the word converse means, this is really easy because we're flipping it around. So we're saying if two lines and a transversal form corresponding angles, like in angles 2 and angle 6, then that are congruent. So if I know angle 2 and angle 6 are congruent, then we can say the lines are parallel. Please write that in on your notes. All right, so let's see how that appears in the real world of our geometry problems. Identifying parallel lines. Let's look at problem number 1. Which lines are parallel if angle 1 is congruent to angle 2? So the first thing I do is any information they give you, I mark it on my paper. So angle 1 is congruent to angle 2, so let's put the congruent arcs for our angles so I can see on my diagram angle 1 is congruent to angle 2. So then we have to decide which lines does that mean are parallel. Your choices are L and M or A and B. And since angle 1 and angle 2 touch A and B, and they're congruent angles, then that would make them corresponding angles. So then we can say A is parallel to B by the converse of the corresponding angles theorem. So using the same diagram, which lines are parallel if angle 6 is congruent to 7? So let me put the congruent marks on here. Angle 6 congruent to angle 7. So if we write this down, if angle 6 is congruent to angle 7, then which two lines? Our choices are L and M or A and B.
A and B. L and M. Thank you.
Which ones do our reds touch? Does the reds touch both B, but neither of them touches A, so it's not A and B. But they both touch M and L. Then L is parallel to M by, that's not, don't do a period, no. Take it away. Converse of the corresponding angles theorem. All right, the proof of the converse of alternate interior angles theorem looks different than any other proof that you've seen so far, which is why I've included it in your notes. I do not expect you to be experts in proofs. This is the first time, probably in your entire math career, that you're experiencing proofs. And just like anything brand new, the best way to become an expert is to get the exposure. So anytime that we have a proof, I show it to you or I have you put it in your notes, because the more you see on proofs, the easier it's going to be for you to create your proofs. And me as a math teacher, I just use proofs that are already written down and then use them as a format. Maybe change the angles, sometimes depending upon where the proof is going, the statements. But as a general format, as a template, it's really helpful. So anytime I can put proofs in your notes, I do. So when your book gives you proofs, I make sure I include them in your notes, because the more you see, the more you write down, the better you'll get at it. You know, two forms of proofs. We've done paragraph proofs and two-column proofs. We started out with two-column proofs where you have a statement and a reason, and usually we start out with our given. Paragraph proofs, it's just converting the statement and the reason into sentences. And then we're going to look at today called a flow proof, where it's like a little flow chart figure where arrows show the logical connections between the statements and the reasons are written below the statement. So it's just a different way, like a third way of writing a proof. So, and I believe if you watch the show Revolution, which is what I do, some of the coding and stuff in there is written as a flow proof. Okay, so we're going to look at the 3-5 Converse of alternate interior angles theorem. So the Converse says if alternate interior angles are congruent, then the lines are parallel. So angle 4 is congruent to angle 6, that's given. And angle 2 is congruent to angle 4 because vertical angles are congruent. Remember yesterday when I had you guys, I'm gonna have you guys write it down here. Remember when I had you write down vertical angles theorem, where vertical angles are congruent? And I include the picture because sometimes the word vertical doesn't always match up with the picture of it. Right here it's vertical, but if I were to draw a 3 and a 4, 3 and 4 would be horizontal to each other. So I wrote this down on my paper. Make sure you guys write this down on your paper. Vertical angles are congruent because this is a theorem that comes up over and over and over again. So I want, anytime you can get exposure to it, I want you guys to write that down. Okay. Angle 2 is congruent to angle 4 because vertical angles are congruent. Okay, so the two together, we're going to take out angle 4 and put in angle 2. If you go 6 is congruent to 4, 4 is congruent to 2. By the transitive property, we cut out that middleman. We can say angle 2 is congruent to angle 6. If I have 2 and 6 congruent, that leads us back to our previous converse of corresponding angles theorem, where line L is parallel to line M. Because if corresponding angles are congruent, then the lines are parallel. All right, let's look at problem 2 together. We're going to write a flow proof of theorem 3-7. If I'm given angle 1 is congruent to angle 7, and we've written the congruency on our picture, yay. I want to prove that line L is parallel to line M. So what they've done is they've written down the given, 1 and 7 are congruent. And we can also say 3 and 1 are congruent because they are vertical angles. 1 and 3 are vertical. That's why I had you write that down, because we use it over and over and over again. So 1 and 3 are vertical angles. So by the transitive property, we can say angle 3 is congruent to angle 7. You see how it's the same format as this proof here. Same format. All they're doing is replacing different angles so we can get to the end result we want. And then we say L is congruent to M. Sorry, L is parallel to M because lines have no dimension. They go on forever, so they cannot be congruent. If corresponding angles are congruent, then lines are parallel. Okay, so we are going to use the diagram from problem 2. So I want you guys to write this diagram below so that you can have experience writing pictures of parallel lines. Come on, give me a, there we go. So write line L, line M, right down at the bottom, or to the right-hand side. To prove theorem 3-6, so we are given angle 3, the measure of angle 3 plus the measure of angle 6 adds up to 180. So here's 3, here's 6. Oops, they're not congruent. So 3 and 6 add up to 180. So just for fun, we'll use flow. So measure of angle 3 plus the measure of angle 6 is equal to 180. By what reason? How can we say that that's true? How did they say it was true? Up here, would we use our template? It's given. The next thing they said was angle 3 is congruent to angle 1. And so what are we going to say about 6 and 7? Or what can we say? All right, so we take our given information and then we put together any information we can say for sure. And we know that angles 1 and 3 are vertical angles. So angle 1 is congruent to angle 3, and that's vertical angles theorem. And so the measure of angle 1 is equal to the measure of angle 3. And that's by the definition of congruence. All right, so we're given that the measure of angle 3 plus the measure of angle 6 is equal to 180. We know that angle 1 is congruent to angle 3 by vertical angles. We talked about vertical angles at the beginning. Then I can say the measure of angle 1 is equal to the measure of angle 3. Given all that information, given all that information, we can flow that into by substitution. We're going to take out angle 3 and put in. No, we can't yet. Because we don't have information about 5. That's going to be our next step.
You do, though, you replace 5 with 6.
So we're going to replace angle 1, or angle 3 with angle 1. So we're going to say the measure of angle 3 plus the measure of angle 6 is equal to 180. and do that by substitution. Oh, sorry, measure of angle 1. So we're taking out angle 3 and putting in angle 1. So we took out angle 3 here. We gave reasons why we can substitute, because angle 1 and angle 3 are the same. We're taking out angle 3 and putting in angle 1 by substitution. We are almost there. So we know that angle 5, so we know that angle 5 and angle 6, measure of angle 5 plus the measure of angle 6 is 180 degrees. Why do we know that? They are supplementary because they are a linear pair.
That's make that.
The linear pair postulate says if two angles are congruent and they form a straight line, then they make a linear pair. And linear pair is supplementary.
Supplementary.
Okay, I'm going to move my picture around one more time. Don't be afraid.
Oh.
Moving my picture around. All right. So let's combine these two together. Is this the only way to do this? No.
No.
There's a bunch of different ways to do this. So we're going to flow this into here. And we're going to say, because both of these are equal to 180, we can say that the measure of angle 1 plus the measure of angle 6 is equal to the measure of angle 5 plus the measure of angle 6. So we can say, since they're both equal to 180, substitution. Substitution says I can replace this 180 with the measure of angle 5 plus the measure of angle 6. Then if I subtract the measure of angle 6 from both sides, I'm left with the measure of angle 1 is equal to the measure of angle 5. By the subtraction property of equality. Okay, I promise there are 2 more steps to this. There are 2 more steps. Yes, this was in previous homework. Okay. So if the measure of angle 1 is equal to the measure of angle 5, then I can say angle 1 is congruent to angle 5, and that's definition of congruence. Congruent angles have equal measure. If angle 1 is congruent to angle 5, then I can say L is parallel to M because corresponding angles are parallel. All right, so here's problem 3. Determine whether lines are parallel. The fence gate at the right is made up of pieces of wood arranged in various directions. Suppose angle 1 is congruent to angle 2. Our lines R and S, R is right here, S is right here, parallel. Explain. So our explanation says, yes, line R is parallel to line S. Angle 1 and angle 2 are alternate exterior angles. If two lines and a transversal form congruent alternate exterior angles, then the lines are parallel. This is the converse of the alternate exterior angles theorem. So the question that you have to answer is, in problem 3, what is another way to explain why R is parallel to S and justify your answer? What do you think, Thomas?
Well, since it says that 1 is equal to 2, and through the vertical angles thing, you can say 2 is equal to 3, and then through the transitive property, we can say 1 is equal to 3 as its corresponding angles. No,
Yes.
as
Yep.
its corresponding angles are parallel.
Yes.
Oh,
Absolutely correct. This is what you guys are writing down. Because angle 2 is congruent to angle 3, because vertical angles are congruent, then angle 1 is congruent to angle 3 by the transitive property. So R is parallel to S by the converse of the corresponding angles theorem. All right, so here's our last problem before the end of this section. So what is the value of X in order for A to be parallel to B? So if you look, what is the relationship between 2x plus 9 and 111? And your choices are, they are either equal measure or they are supplementary. So this angle here and this 111 here, are they supplementary or are they congruent? So the way I tell is, I take a look at, is this acute or obtuse? This is acute. Is this acute or obtuse? Obtuse. If it does not look the same, definitely is not. And when you're dealing with parallel lines. So we say that 2x plus 9 added to 111 is equal to 180. That's the definition of supplementary angles. So 2x, we simplify 2x plus 120 because you add the 9 and the 111. You subtract 120 from both sides. You get 2x equals 60 and x equals 30. So x equals 30 would make these two lines parallel. So we are going to do the same thing for number 4. And we have to look, is this angle here congruent or supplementary to 3w minus 2? Congruent. If they look the same, they are the same with parallel lines. So we are going to set them equal to each other because congruent angles have equal measure. And that is definition of congruence. And we go add 2 to both sides. And that's a subtraction. Or add 2, sorry. The opposite of minus is adding. So that's 57 equals 5w. The next step would be, is it 3?
Yes.
Oh, thank you. Good, because my math was going to be really difficult in this assessment. That's much better. Thank you. 57 equals 3w, so I'm going to divide by 3. $57 divided by 3, 3 goes into 5, 1, put 2 left over, 3 goes into 27, 9 times. Hello, mental math, W is equal to 19. And that's the value of W that would make C parallel to D.